All right, friends, it's time for another Leetcode question. So today we're doing Leetcode question number 1725, number of rectangles that can come from this largest square. You are given an array of rectangles where rectangles I equals Li with I. Represents the ith rectangle of length Li and width I. You can cut the ith rectangle to form a circle, not a circle, form a square with a side length of k. If both k is less than or equal to I and k is less than or equal to wi. For example, if you have a rectangle 4, 6, you can cut it to get a square with a side length of at most 4. Let max len be the side length of the largest square you can obtain from any of the given rectangles. Return the number of rectangles that can make a square with the side length of max len. All right, so just a quick recap. We're going to be given an array of an array, or a vector of a vector, and it's going to have two coordinates. It's going to have the length, and then it's going to have the width. So out of these, we have to make a square out of the dimensions that we're given. So in order to make a square, it has to be proportional. So whatever the lowest number is, whatever the lowest number between these two numbers are, is the size of the square that we can make. Because obviously we can't grow the rectangle so that it turns into a square. So like we can't have, convert 5 to 8 and then have this be a proportional square. We can only pretty much chop up the rectangle to get an even square. So as you can see here, the largest squares you can get from each rectangle are lengths 5, 3, 5, 5. The largest possible square is of length 5, and you can get it out of 3 rectangles. So that's how we get the result. We get the result of, so we're going to be returning the number of rectangles that can make a square with the side length of max len. So in order to solve this issue, we're going to make a couple variables here to start it off with. So the first variable we're going to make is we're going to make our max vector. So what this is going to do is this is going to give us, we're going to store the difference or the smallest number between these two numbers. So we're going to go ahead and initialize that here. We're going to make a temporary variable to make it easier for us to check later on, because once we have all these numbers within our max variable, we want to iterate through our max variable and compare it. Compare each entry against itself. And so in order to do that, we want to store one of the variables into like a temporary variable just to make it easier for ourselves. And then our last variable is going to be a result variable. So we're going to use this to return the result. So first, we're going to make a for loop because we have to iterate through the rectangles vector that we're given. So int I equals 0, I is less than rectangles dot size, and then I++. So thankfully, since we know that the rectangle length will always be 2, we can hard code some of the functionality here. So we don't need another for loop to like iterate through all the entries within the vector. We know for sure that there's going to be 2 variables here. So what we can do is we could do max.pushback, and then we're going to do min rectangles I, rectangle 0, and then rectangles I 1. Okay, we need to make sure we don't forget the other parentheses here. Okay, we have enough parentheses. So what we're doing here is we're iterating through each entry. And so whatever the minimum number between, I think this will throw an error actually, I need to remove that. So whatever is smallest between the first verse value and the second value, we're going to add that value into our max vector. So now what we're going to do is once everything's added through, we're going to do another for loop. different I equals 0, I is less than. So now we're going to do the max vector, so max.size. And then we're going to increment it by 1. And so what we're going to do here is we're going to make a simple check. So if our temporary variable is less than max.i, what we're going to do here is we're going to have our temporary variable equal to max.i, and then we're going to have our result equal 0. So the reason why we're having our result equal 0 here is just in case we get a, so let's say we get like a really big array and the minimum ends up being different. We could pretty much avoid this by sorting the algorithm, but I think it loses a bit of efficiency if we sort it. So this just helps us if saying this just in case there's a number that ends up being bigger. So like let's say there's two 5s and then there ends up being 3 8s. So we want to reset the result to 0 so that we get the accurate result for the 3 8s in our hypothetical situation. All right. So next, what we want to do is we want to test if temp is equal to max I, and then we just increment this. We increment our result by 1, and then once we're out of that loop, we just return our result. And yeah, that should be it. So let's go ahead and run it, make sure it works. And it doesn't work. Oops. Let's see. Okay, I put an L instead of a... Oops. Oh my goodness gracious. I put an L instead of a semicolon. And we got green. And yeah, that's pretty much it, guys. That's my solution for this problem. Hopefully you guys enjoyed it. Hopefully you found it helpful. I want to say the time complexity for this is O of n, because depending on the amount of values are within this vector here, the worst case is going to grow exponentially, or not exponentially. It's going to grow linearly the more values that are inside this rectangle's vector. So that's why this has a time complexity of O of n. And yeah, hope you have awesome